गुड मॉर्निंग एवरीवन। हाउ आर यू ऑल? कैसे हो आप सब लोग? आपको आवाज क्लियरली आ रही है? आप क्लियरली सुन पा रहे हो मेरी आवाज? आपको स्क्रीन पे प्रॉपरली दिख पा रहा है? वीडियो अटक तो नहीं रही? एक बार आप चैट सेक्शन में कमेंट करके बता दीजिए। आपको वॉइस क्लियरली सुन पा रही है? आर यू एबल टू लिसन टू मी क्लियरली? काइंडली कमेंट इन द चैट सेक्शन एंड टेल मी। आप एक बार बता दीजिए चैट सेक्शन में कमेंट करके कि आपको वॉइस क्लियरली सुन पा रही है। हम फिर लेक्चर शुरू करेंगे। तो okay, we'll start. So, hello everyone. My name is Rohan Goyal, and I am your civil engineering faculty at Engineering Hotspot. And in today's lecture, we are going to look at a few of the GATE 2020 set 2 questions of reinforced concrete structures subject. So, we are going to discuss questions from the RCC that are asked in GATE 2020 set 2 question paper. So, I have shown the first question on the screen, and I would like you guys to first read this question properly, and if you know the answer to this question, comment in the chat section and tell me what is the correct answer to this option. Read the question and tell me the answer to this question. Okay, we will read the question now. So, in this question, the first question that is from the subject of reinforced concrete structure in GATE 2020 set 2 paper is, as per IS 456, the pH value of water for concrete mix shall not be less than. We are given four options. A option is 4.5, B is 5, C is 5.5, and D is 6. So what is the correct option to this question? In the question, इन्होंने पूछा है कि जो pH of the water कितने से कम नहीं होनी चाहिए concrete mix के लिए. For preparation of the concrete mix, pH of water shall not be less than what? IS 456 में ये clearly mention किया गया है that the pH of the water shall not be less than 6.0. The correct option to this question is C, D, that is 6. The pH of the water shall not be less than 6. This has been given in the clause 5.4.2. Let us see, let us look into the IS 456 2000 and see what does this clause say. So over here I have opened this clause. So 5.4, clause number 5.4 is on the water. So what type of water shall be used in the preparation of the concrete mix? Water used for the mixing and curing shall be clean and free from injurious amounts of oil, acids, alkalis, salt, sugar, organic materials or other substances that may be deleterious to concrete or steel. So it starts like this, and it tells you about what type of the water shall be used for the concrete mix design. And if we see the clause number 5.4.2, it is mentioned over here. 5.4.2, it is mentioned over here, the pH value of the water shall not be less than 6. So the answer to this question is 6. So I don't think that there will be any doubt in this question. So we'll move on to the next question. The next question over here is also, now this question was the previous question that we discussed is a 1 marks question. Information based question. So very easy, very straightforward. You just have to read the IS 456 at least 2 times before you go for GATE examination or IES examination. IS 456 2000 shall be read at least 2 times and should be read thoroughly. You will see various questions from IS 456 in various competitive exams. When we will be discussing RCC, the whole subject on a channel, I'll be going through the IS 456 in detail, and I'll be viewing the IS 456 side by side as we are teaching, as we are studying RCC. So I'll make sure that each and every student who will be studying RCC from me will be able to study and read IS 456 with ease. So we'll move on to the next question now. The next question over here is on the split tensile strength of the concrete. So first read this question properly and try to understand what the question is saying. And if you know how to solve this question, solve it quickly and tell me the answer in the comment section. अच्छे से रीड कीजिए क्वेश्चन को, समझने की कोशिश कीजिए क्वेश्चन को, क्या कह रहा है क्वेश्चन. हर एक क्वेश्चन को गेट में, ईएससी में, किसी भी कॉम्पिटिटिव एग्जाम्स में, कोई भी आप अटेंड करते हो, एक बार आप क्वेश्चंस को अच्छे से रीड जरूर करना. मैं हमेशा कहता हूँ अपने लेक्चर्स में कि कई बार क्या होता है कि इवन दो यू डोंट नो द टॉपिक विच इज आस्क्ड इन द क्वेश्चन, यू हैवंट स्टडीड द concept which is asked in the question or from the topic from which the question has been asked, but if you read the question properly, sometimes the question is framed in such a way that you can solve the question regardless of having the knowledge of that topic through your basic reasoning or aptitude capabilities. So it becomes very important for you to read the question twice before attempting that question. So एक अच्छे से क्वेश्चन आपने रीड कर लिया होगा अभी तक, तो पढ़ते हैं क्या क्वेश्चन क्या कहता है. व्हाट डज द क्वेश्चन सेज, लेट अस रीड इट आउट. सो द क्वेश्चन सेज दैट द मैक्सिमम अप्लाइड लोड ऑन अ cylindrical concrete specimen of diameter 150 mm and length of 300 mm tested as per the split tensile strength test guidelines of IS 58161999 is this. So in the question, the maximum applied load is given at which a cylinder of specimen of dimensions of diameter 150 mm and length of 300 mm is tested as per the split tensile strength test, and the maximum load implies that the specimen fails at 157 kilonewton. Now this IS 5816 is a code given by the Indian standards to give the guidelines how this test shall be conducted. Now in the question it has been asked the split tensile strength in megapascal rounded off to the 1 decimal place of the specimen is. Now the split tensile strength of the specimen is asked in this question. Now let us see briefly how this test is conducted. Now first a cylindrical specimen is taken. This test is conducted on UTM itself, on which the crushing strength test is also conducted. So for this test, a different separate instrument is not used, the same instrument is used. So this is a cylindrical specimen of 150 mm depth. This is the standard dimensions of the cylindrical specimen used for the split tensile strength test. 150 mm diameter and 300 mm length cylinder is used for the test. And this specimen is subjected to the split tensile strength test. In this test, what is done is a compressive load is applied along the circumferential edge of the cylinder. That is the line of action of the compressive stress is as shown in the diagram. And because of this compressive stress, what happens is, if we see the cross section of this specimen, now because of this compressive stress, there will be a tensile stress in the lateral direction. So there will be a tensile stress in the lateral direction. And due to which cracks are developed. Due to this, as we know that the concrete is weak in tension, so the concrete gets cracked along the line of action of the compressive stress because of the tensile stress in the lateral direction. So at the moment at which these cracks are developed, the load at which these cracks are developed is found out to be 157 kilonewton as given in the question. And it is asked what is the split tensile strength represented by sigma Tc, tensile strength of concrete split on a split cylinder strength test. What is the split tensile strength of the specimen? Now, using the theory of elasticity, the formula that gives the split tensile strength of the specimen subjected to the split tensile strength test. Theory of elasticity के according split tensile strength जो होती है उसके लिए फॉर्मूला जो यूज किया जाता है थ्रू ऑफ अ स्पेसिमेन दैट जिस पे स्प्लिट टेंसाइल स्ट्रेंथ टेस्ट कंडक्ट किया गया है वो होता है सिग्मा TC, sigma tensile strength of concrete subjected to the split tensile strength test is equal to 2P, P max or the P at the failure point, P max or the P at the failure point divided by pi D is diameter of the specimen, L length of the specimen. So we are given all the values in the question. Straightforward, you just need to remember this formula in order to solve this question. So 2 P max is 157 kilonewton. Since the answer to this question is asked in megapascal, that is Newton per mm square. That is Newton per mm square is asked in the question. So we will change 157 kilonewton into Newton, multiplying it by 1000 10 to the power 3, 157 into 10 to the power 3 Newton divided by pi into diameter is 150 mm multiplied by length is 300 mm. So the resultant units will be Newton per mm square or megapascal. So the split tensile strength we can calculate using this formula. So it will be 2 multiplied by 157 exponential 3 divided by pi divided by 150 divided by 300. So the answer comes out to be 2.22109. So 2.2211 we can say 2.2211 megapascal. Now in the question it is asked that we have to round off to the 1 decimal place. So rounding off to the 1 decimal place, it will be 2.2 megapascal. So the answer to this question will be 2.2 megapascal. So any doubts in this question? Do you have any doubt in the question? Comment in the chat section and tell me if there is any doubt in the question. Is there any doubt in this question? Comment and tell me. Okay, Shushmita. So we will proceed to the next question now. So first read the question carefully and try to understand what the question says. एक बार अच्छे से क्वेश्चन को अच्छे से पढ़ लीजिए. Take a 1 minute time and read the question twice and try to understand what the question is saying and what the question is asking, what has been asked from the question. अच्छे से एक बार क्वेश्चन पढ़ लीजिए आप. The last question that we discussed was a 1 marks question. It was a straightforward question, formula based question. It will hardly take 30 to 40 seconds to solve that question. So it was a 1 marks question which was asked in GATE 2020 set 2. So I hope you have read this question. Now we will proceed to this question and we'll read this question. What does the question says? Now this is a 2 marks question that is asked. 2 marks question. So let us read what the question says. Now in the question it has been asked, a concrete beam of span 15 meters, 150 mm wide and 350 mm deep is pre-stressed with a parabolic cable as shown in the figure. It is shown in the figure a parabolic cable or the pre-stressing tandem which is provided in the parabolic form in a concrete beam of dimensions 15 meter length and the cross-section dimension of 150 mm wide and 350 mm deep. Further, it has been given the coefficient of friction for the cable is 0.35 and the coefficient of wave effect is 0.0015 per meter. If the cable is tensioned from one end only, the percentage loss rounded off to the 1 decimal place in the cable force due to the friction is. Now it is asked the percentage loss in the cable force or the pre-stressing force due to the friction. So in the question we need to find loss in the pre-stressing cable due to friction. So we need to find the loss in the pre-stressing cable, stress in the cable due to the friction. Now PL represented by the loss in the pre-stressing force in the cable is equal to P naught. P naught is the initial pre-stressing force in the cable multiplied by Kx plus mu alpha, where K is the coefficient of wave effect, X is the length of the cable, mu is coefficient of friction, and alpha is the angle of deflection of the cable. So if we know the value of K, the value of K and mu has already been given in the question, and we need to ask the percentage loss. So what is the percentage loss? How you will calculate the percentage loss? Over here we are getting the loss. PL is the loss in the pre-stressing. It is not the percentage loss. What we need to calculate is the percentage loss. So from here you can understand that how important is it to read the question carefully and see what actually is asked in the question. A student while attempting any examination will be under a lot of pressure, and under that pressure, and he would be he would have known how to calculate the pre-stressing losses due to friction, but due to that pressure he might not have read the question properly, and instead of giving the answer as the percentage loss, he would have quickly written the answer of the pre-stressing loss and could have lost 2 marks. So what is the percentage loss? Percentage loss will be or PL percentage is equal to PL, the loss in the pre-stressing, divided by the initial pre-stressing force multiplied by 100. So this is the percentage loss. What is asked in the question is P percentage loss. So we from this expression we can say that the percentage loss will be PL upon P naught is how much from the equation, from this equation, from equation 1, percentage loss or percentage loss is equal to PL divided by P naught into 100 is equal to Kx minus plus mu alpha multiplied by 100. Now what is the value of X and alpha? What is the value of X and alpha? So X is what? X is the length of the cable upon which the pre-stressing is taking place. Now, since it is given in the question that the cable is tensioned from one end only, over here it is given in the question that the cable is tensioned from the one end only. So let us see how the tensioning is taking place. Let us see through this diagram. Now what is happening is, suppose this end of the cable, this end of the cable is fixed. This end of the cable is fixed, and this end of the cable is tensioned. This end of the cable is pulled out. Since this type of losses take place in a post-tensioned concrete sections, so what happens is first the concrete section is casted, and there are ducts laid within the concrete section for the steel to be embedded into them. Once the concrete section is casted and cured, the steel is embedded into those ducts, and it is fixed at the one end, and then from the other end it is pulled through jacking. It is also known as jacking from one end. So a load is applied P from the other end, and the bar is pulled out so that the concrete section gets under pre-stressing force. Now when this bar is pulled out, there is a friction force along the length of the cable, like this. Any doubts? There will be a friction force along this length. Now this friction force is calculated using two factors. This friction force, due to this friction force, what happens is, suppose we need a pre-stressing force of 1200 kilonewton or 1200 megapascal. We need a pre-stressing force of 1200 megapascal along the length of the cable. Now due to the friction, what will happen is, when the cable is stressed to 1200 megapascal at this end, when the cable is subjected to 1200 megapascal, due to friction, what will happen that as we move from this point to this point, there will be loss of, let us say, 50 megapascal. So at this point, the pre-stressing force that will be left is equal to 1150. And as we move further away, another, let us say, 50 megapascal is lost. So at this point it will be left with 1100, then 1050, then 1000, then 950, then 900, then 850, and then 800. So this loss of the pre-stressing force due to the friction along the cable length has to be taken into consideration. Now this has been taken into consideration using two factors. First is the length, due to the length of the cable. First is the loss due to the length of the cable, and another one is the due to curvature of the cable. Now due to the length of the cable, now when the pre-stressing is taking place for the one end only, when the jacking is done from the one end only, the whole length of the cable is facing the resistance. So the length, this loss, let us say PL1, is equal to P naught into Kx, where K is what? Coefficient of wave effect, and X is the length of the cable through which the resistance is taking place. So over here, since the jacking is done from the whole one end, so the whole cable, as you can see, is subjected to the resistance. So over here X is equal to L for jacking or tensioning from one end only. Now if this tension has been done from the both the ends, now if this tensioning has been done from both the ends, now say that from both the ends the tensioning is done, from this end also and from the other end also. Now what will happen is that the resistance will be there as shown. So suppose again we are tensioning it to 1200 megapascal and both the sides we're tensioning it to 1200 megapascal. Now due to this losses at this section, let us say 50 is lost. So 1150, over here also it will be 1150. Then up to here it is 1100. Then over here it is again 1100. Over here it is 1050. Over here is also it is 1050, and at the midpoint it will be 1000. So the pre-stressing force that is left at the end is 1000, and throughout the length it is more than 1000. As if we compare it to the previous case, it has reduced down to up to 800. So we can see clearly that when the tensioning is done, when the jacking is done from both the ends, the effective loss in the pre-stressing is lesser than in this case than in the previous case. Am I right? So this is a case of jacking from both ends. Now we can say that the length which is taking the resistance for a particular jacking will be L by 2. Let us see the half of the section of the beam. So over here the tensioning is done, and this part we can assume that this part is fixed, and the length upon which the resistance is offered is this whole length is L. So this will be how much? L by 2. So the effective length through which the jacking is taking place is L by 2. So X is equal to L by 2 when jacking or tensioning from both ends. So this is the concept in the background of this question. So in the question, although in the question it is given that the cable is tensioned from the one end only, so the length that will be taken into consider will be the full length, that is the 15 meter. So we know the value of x over here. So we know the value of x is equal to 15 meter. Now what we need to find is the alpha. Alpha is due to the effect of the curvature of the cable. Now let us rotate, let us clear the diagram. Now since the cable given in the question is having a curvature like this, due to this curvature also there is some additional friction, and due to this additional friction also there are some additional pre-stressing losses. Now these pre-stressing losses are calculated using the formula PL is equal to P naught multiplied by mu alpha, where mu is the coefficient of friction and alpha is the angle of deflection or of the cable or the curvature of the cable. Now since the tensioning is taking place from the one end only, so the resultant curvature through which the tensioning is taking place is like this. Okay. So now since the tensioning is taking from only one place, so the whole cable is deflected by the angle alpha, this angle. So this is the total angle alpha that through which the cable is deflected and the tensioning is taking place through the whole deflection angle. So this alpha will be how much? Now the cable, the equation of the parabolic cable is what? Y is equal to 4h upon L square into x into L minus x. This is the equation of the cable or the equation of the parabola, we can say, where y is the, so this is x and this is y. So at a given x, this y, the value of y is as this, and the value of h is the, what is the h? Is the maximum deflection of the parabola from the x-axis, that is equal to 70 plus 50 is equal to 120 mm. So h is equal to 120 mm and L is the length, that is 15 meters. Now we need to find this angle. Now at x is equal to 0, dy by dx or tan theta can be calculated. So dy by dx is equal to how much from this above expression is equal to 4h upon L square into L minus x minus x. So it is how much? 4h upon L square into L minus 2x. y by dx. So at x is equal to 0, dy by dx is equal to how much? 4h by L. So since this is equal to tan theta and theta is very small as compared to the length of the member, the angle is very small, so tan theta is almost equal to theta, so theta is equal to 4h by L. Now this angle over here is how much? This theta is 4h by L. Now similarly this angle will also be theta, and using the parallel axis theorem, this angle is theta, then this angle is also theta, and this, if this angle is theta, then this angle is also theta, and this is 4h by L, this is also 4h by L. So alpha is equal to 4h by L plus 4h by L, which is equal to 8h by L. So from here we got that alpha is equal to 8h by L when tensioned or jagged from one end only. Now we know the alpha when the when the pre-stressing cable tandem or the pre-stressing cable is tensioned from the one end only. Now let us see if the jacking is done from both the ends, what will be the value of alpha? We'll clear this diagram. Now since the jacking is done from both the ends, now this, if we take the effect of only one side of the jacking, it can be seen from the below diagram, and the angle through which and the curvature through which the jacking will be done will be okay. Okay, so okay, so this is the angle alpha for which the jacking will be done from one end only, if the jacking is done from both the ends. So from both the sides, it will be like this. Okay, so this will be the alpha angle, and similarly from this end also, this will be the alpha angle. So this alpha angle will be equal to this angle theta, which is 4h by L. So the alpha will be how much? In this case, 4h by L. Alpha will be equal to 4h by L only. Any doubts? Because we are the resultant effect is only on the half of the cable. As the tensioning is done from both the ends, so alpha value will be only 4h by L. So alpha is equal to 4h by L. When the jacking or tensioning is done from both ends. So I hope the background is clear. If you have any doubt, you can ask me. You can comment in the chat section and you can ask me whatever the doubt may be. If you didn't understand any point in this discussion, you can tell me. I can repeat that point again. Is there any point you didn't understand? So, okay, we'll proceed. So, now we know what is the value of x and alpha for the question. Now, alpha is how much? Is equal to 8h by L. Now, h value is how much? 8 multiplied by 120 mm divided by L is 15 meters multiplied by 1000 converted into mm. So, we know the value of alpha. So, let us calculate the percentage loss. So, percentage loss or PL percentage is equal to PL divided by P naught multiplied by 100 is equal to Kx plus mu alpha multiplied by 100 is equal to K is given as how much? That is the wave coefficient of wave effect, that is 0.0015 per meter length multiplied by per meter length multiplied by the length, that is L, that is 15 meters, plus mu is coefficient of friction, that is 0.35 given in the question, multiplied by the alpha. Alpha that we just calculated is 8h by L. 8 into h is 120 mm divided by L is 15 meters converted into mm, 10 raised to power 3 mm cancels out. So this expression also, this expression is unitless. This is per meter into meter, this expression is unitless. So the units are uniform throughout the equation multiplied by 100. So let us solve this. So it is 0.0015 multiplied by 15 plus 0.35 multiplied by 8 multiplied by 120 divided by 15 exponential 3 multiplied by 100. The whole expression multiplied by 100. So it is 4.49 percentage. The percentage loss is how much? 4.49%. Now in the question it is asked to round off to the one decimal place. So 4.49 rounded off to the one decimal is equal to 4.5. 4.5%. The answer to this question will be how much? The percentage loss is 4.5% loss. Any doubts up to this point? Any doubt in this question? Is there any doubt in this question? Is this question clear? Yogesh, Shushmita, is there any doubt in this question? You can chat and tell me anytime. Okay, so we will proceed to the next question now. So the next question, I would like you guys to first read out this question again. Read this question and try to understand what the question is saying. Read this question thoroughly. Read the question. Try to understand what the question is saying and what has been asked in the question. So, okay, let's read the question. What does the question says? In the question, the cross section of the reinforced concrete beam, the cross section of the reinforced concrete beam having an effective depth of 500 mm is shown in the figure. In a figure is shown for a beam and the cross section of that beam is shown having effective depth of 500 mm. The grade of the concrete and the steel used are M35 and Fe550. The concrete and the steel used for this beam has been given in the question. The area of the tension reinforcement is 400 mm square. It is given that the corresponding to 0.2% proof stress, the material safety factor of 1.15 and the yield strain of Fe550 steel is 0.0044. So the yield strain is given taking 0.2% proof strain and a factor of safety of 1.15 of Fe550 steel. So as per IS 456-2000, the limiting depth of neutral axis measured from the extreme compressed fiber is. So in the question, the limiting depth in mm of neutral axis is asked, measured from the extreme compressed fiber. So a section is given, the value of the yield strain is given for the steel, and the value of the yield strain for the concrete on the extreme compressed fiber in bending, under bending, is given in the IS 456-2000, and we need to find out the limiting depth of the neutral axis. So let us see how this question will be solved. So let us assume this is the neutral axis. So this is the limiting depth of XU limiting, which is required to be found. Now the limiting section, or the section having a neutral axis at a limiting depth, is the section in which both the steel and the concrete will reach the yield strains or the failure stage simultaneously. Limiting depth of neutral axis, अगर एक सेक्शन की लिमिटिंग डेप्थ ऑफ न्यूट्रल एक्सिस फाइंड की जाती है टेकिंग इन कंसिडरेशन that both the concrete and the steel reach the yield condition or the yield strain or the failure stage simultaneously एक साथ at the same time. So as we know, the first assumption in the limit state method is that the plane section remains plane before and after bending. Now this assumption makes sure that the section is following the strain compatibility, that is the strain distribution throughout the depth of the cross section is linear. So if we draw the strain distribution, okay, so the strain in the extreme compressed fiber of the concrete, this is the strain distribution diagram. So this is the compressive strain and this is the tensile strain. Compressive strain in the concrete and tensile strain in the remaining section. So as per IS code clause 38.1, let us see. Let us open the IS code and see what does this clause say. Clause 38.1. Okay. In this clause, the clause 38, the assumptions has been given in 38.1, assumptions has been given that has to be taken into consideration while designing a concrete structure using limit state method. So the first assumption is so let us read what are the assumptions. The design for the limit state of collapse in flexure shall be based on the assumptions given below. So the design in flexure of the flexural members. So the design of the flexure members, one second. Okay. So for the design of the flexural members. So the first assumption A, assumption that the plane section normal to the axis remain plane after bending. So this assumption is signifies that the strain compatibility is ensured through this assumption. Now then a stress strain curve for the concrete is given. Now the first line, the first FCK stress strain curve is given. It is parabolic up to a strain of 0.02 and then it is straight up to 0.0035. Since the material behavior of concrete is very unpredictable and there is a lot of variation in the strength of the concrete for different sets of mixes, so that's why the factor of safety that is used in the designing is there are two. First of all, while designing, the strength of the concrete is taken as only 0.6 times of FCK. As that is that the strength of the concrete that is taken into consideration is only 0.067 FCK and a partial factor of safety is applied over this strength, that is gamma m. A partial factor of safety is applied over this length, over this strength, that is gamma n of 1.5. So this is the design curve that is used for the designing, and this value of the value comes out to be 0.45 FCK. So in flexure at failure, the strain in the concrete is 0.0035. When the extremely compressed fiber of the concrete reaches this strain value, it is assumed that the concrete section has failed. Then the assumption B is given. The assumption B says that the maximum strain in concrete at the outermost compressed fiber is taken as 0.0035, as I have told earlier in bending. Okay. Now in this section, in the C assumption, the relationship between the compressive stress distribution in the concrete and the strain in concrete may be assumed to be rectangular, trapezoidal, parabolic, or any other shape which result in prediction of the strength in substantial agreement with the results of the test. An acceptable stress strain curve is given in the figure 21. For the design purpose, the compressive strength of the concrete in the structure shall be assumed as 0.67 times of the characteristic strength. The partial factor of safety of gamma m is equal to 1.5 shall be applied in addition to this. So in this, it is given that the stress strain curve can be taken either rectangular, trapezoidal, parabolic, as it is as the results of the test is can be agreed upon. So whatever the test that you conduct on the concrete specimen, and using the test result, you can assume the stress strain distribution to be any of these depending upon the results. And in the next line, it is given that the design compressive strength of the concrete is taken as 0.67 times the characteristic strength, as I have told earlier, and a partial factor of safety of 1.5 is applied over this. So after applying the partial factor of safety, we got the characteristic that the design strength of the concrete is 0.45 FCK. That also I have told. So this is not related to this question, but I have told this in addition. So we'll see what we'll come to the point, and if we see the assumption number F over here, the assumption number F. In the assumption number F, it is given the maximum strain in the tensing reinforcement in the section at failure shall not be less than Fy upon 1.15 plus 0.002. Now from where does this value comes from? Now if you see this graph is in this graph it is given the stress strain curve of the reinforcing steel. So we'll take this, we'll study this separately. So for the steel, the stress strain curve is like this. So let us take it for as given in the question Fe 550 steel. The stress strain curve is carried out. Initial section of the steel is linear and then it is non-linear up to failure. And for taking, since there is no defined yield point, so the yield strength is taken at a 0.2% proof stress as given in the question. So you can see over here in the question, the corresponding to 0.2% proof stress, the material factor of safety of 1.15, the yield strain of Fe 550 steel is, yield strain of Fe 550 is 0.0044. So let us say this graph is for Fy. Now applying the factor of safety Fy upon 1.15, you will get this stress strain diagram. Now for 0.2% proof strain value, so this is 0.002, that is percent converted into decimals. Now take a straight line parallel to the this line. Draw a straight line parallel to this line. Now this is the point at which it joins the stress strain diagram will be the yield strength of the steel after applying the factor of safety. So this is sigma y, sigma st, yield strength of the steel, or sigma y, and the strain, and since this is the Young modulus of steel, Es, so this value will be how much? This is equal to, now Fy is yield strength, so this is Fy will be equal, sigma y will be equal to Fy upon 1.15, yield strength of the steel without factor of safety divided by 1.15, that is factor of safety. So we know this value, we have to calculate this value. Young's modulus is equal to stress upon strain. So stress is equal to, so strain is equal to stress upon Es. So strain is equal to stress is how much? Fy upon 1.15 into Es. So it can be also written as 0.87 Fy upon Es. So this value is Fy upon Es. So this is how much? This value 0.87 Fy upon Es. So the total strain at the yield point will be how much? At yield condition, strain in reinforcement is equal to 0.87 Fy upon Es plus 0.002. So this is the value that is given over here in the code, Fy upon 1.15 Es plus 0.002, and this particular value itself is given in the question also. So in the question also, it is given that the corresponding to 0.2% proof stress, the material safety factor of 1.15 and the yield strain of Fe550 steel is 0.0044. So this value itself is given as 0.0044. So now we know the maximum strain in the extreme compressed fiber of concrete will be how much? 0.0035, and in the steel will be 0.0044. So what is the limiting depth at which both the concrete and the steel reaches the yield condition simultaneously? So we can calculate this easily using the similar triangle. Okay, so if we see this triangle, the above triangle, this triangle, and the below triangle, and comparing these two triangle, since this depth is actual limiting, so this remaining depth will be how much? Now the effective depth is also given as 500 mm, D is given as 500, so this will be how much? D minus XU limiting. So comparing these two, 0.0035 divided by XU limiting, or 0.0035 divided by 0.0044 will be equal to XU limiting divided by D minus XU limiting. Any doubts? कोई डाउट है यहां तक? इस एक्सप्रेशन में कोई भी डाउट है? और यहाँ कोई भी यहाँ तक हमने जो भी ये पॉइंट्स डिस्कस किए, इनमें कोई भी डाउट है आपको? एक बार टेक्स्ट चैट सेक्शन में बता दीजिए कि आपको इसमें कोई भी डाउट है। आप किसी भी पॉइंट पे मुझे चैट सेक्शन में कमेंट करके बता सकते हैं अगर आपको किसी भी पॉइंट पे कोई भी डाउट आता है। आई विल क्लैरिफाई योर डाउट इमीडिएटली। तो चलो ठीक है, इस एक्सप्रेशन को सॉल्व करते हैं और एक्चुअल लिमिटिंग की फटाफट हम वैल्यू निकाल लेते हैं जो क्वेश्चन में पूछ रखी है। तो let us cancel all this. Let us light is 35 multiplied by 10 raised to the minus 4 divided by 44 multiplied by 10 raised to the minus 4 is equal to XU limiting divided by D is given as 500 mm minus XU limiting. So both this 10 raised to the minus 4 cancels out. So 35 multiplied by 500 minus XU limiting will be equal to 44 multiplied by XU limiting. Okay, so solving this, 500 multiplied by 35 is equal to 44 plus 35 multiplied by XU limiting. So XU limiting will be equal to 500 multiplied by 35 divided by 79. Okay. So let us calculate this. 500 multiplied by 35 divided by 79. So it is 221.519. So 221 1.519 mm, and it is asked in the question to round off to the nearest integer. So in the question it is asked to round off to the nearest integer. So rounding off to the nearest integer will be how much? 221 mm, or you can also write it as 220. Let us take it as 222 mm. So the answer is, you can write either 221 mm or 222 mm. Let us see what is the range given in the solution. 43. So it is from 220 to 224. The answer to this question is between 220 to 224. So your both these answers lie within the range. So this the answer could be any of these options. So from here we have calculated the limiting depth of the neutral axis for the given section. Now if you have noticed, many of the values that has been given in the question are useless or are of no use. For example, the grade of concrete, area of steel, width, width, width of the web, width of the flange, depth of the flange. All these values are useless or redundant. These values are given only just to confuse the student. So do not get confused. Keep your concepts clear. And if your concepts are clear, how to find out how the limiting depth is found for any given section. अगर आपका इतना कॉन्सेप्ट क्लियर है तो आपको सोचने की ज्यादा जरूरत नहीं पड़ेगी और आप डायरेक्टली आप आंसर निकालने पे फोकस्ड होंगे और आपको इन सब चीजों पे इन सब एक्स्ट्रा इंफॉर्मेशन पे ध्यान जाएगा ही नहीं. अगर आपके कॉन्सेप्ट क्लियर है तो आप फोकस्ड होंगे आपने कॉन्सेप्ट्स पे और उनको आप उन्हीं पे फोकस करके आप अपना सोल्यूशन निकाल ले जाओगे. आपका दूसरी रिडंडेंट चीजों पे ध्यान जाएगा ही नहीं कि क्या दे रखा क्या नहीं दे रखा. आपका उन्हीं चीजों पे ध्यान जाएगा जो जो आपको चाहिए होंगी. तो इसीलिए आप अपने कॉन्सेप्ट हमेशा क्लियर रख रखें. गेट में बहुत बार ऐसे क्वेश्चन पूछे जाते हैं जिसमें रिडंडेंट इंफॉर्मेशन बहुत दी जाएगी. तो आप अच्छे से पढ़ें और बेस्ट ऑफ लक और आप अच्छे से तैयारी करते रहिए. हम रिमेनिंग सॉल्यूशंस अपलोड करते रहेंगे. हमने यहाँ पे रीइंफोर्स्ड कंक्रीट स्ट्रक्चर्स के सारे क्वेश्चंस गेट 2020 सेट 1 एंड सेट 2 हमने कंप्लीट कर दिए हैं सॉल्यूशंस. गो टू द प्लेलिस्ट of our channel on GATE 2020 test series and you can view the solutions of the geotechnical questions also and the RCC questions also. Or I'll be coming live every day at 10:30 a.m. So keep posted and keep watching. Subscribe to the channel and press the bell icon to get notified whenever I am online. So wish you best of luck. Have a nice day. Goodbye.